Hello, my name is Danielle Lindquist, and I'm one of the lead engineers with the San Francisco Bay Aquarium. Today I'll be talking about the feasibility of reducing marine plastics within the San Francisco area. First, before I dive in, I'm going to share a story. Part of my oversight is also looking at some of the research of our fellow researchers. And lately we have been discovering that there's been a lot more marine plastics in our area. Take, for example, a sea turtle. This is a sea turtle's throat. When a sea turtle eats plastic, it goes into its stomach. But as its unique biology has it, when it tries to regurgitate water and some of the plastic back up, it fails to do so. The plastic gets caught on these needle-like structures you see in its throat, therefore making it so it cannot regurgitate the plastics. This is very fatal for the sea turtle because the stomach will send a message to the brain saying that it is full, when in actuality it may have not eaten actual food in a long time. This will cause the sea turtle to slowly starve. And this happens not just with sea turtles, but other various marine life, such as dolphins and sharks. So, to help curb, I wanted to help reduce the marine plastics that we see in our oceans and rivers. So, to help achieve the feasibility, I have broken down this speech into two parts. First, I'll be talking about river systems we can implement, and then second, I will talk about ocean systems that we can implement. From there, the first I will be talking about is the river systems. I'll be talking about two main river systems that we can implement. The first being the man-powered boats. These boats are 1 to 2 man-powered, and they are more meant to help in general ways of cleaning and maintaining rivers and waterways. These boats are very flexible with what they can do, but today I'll be focusing on the honorary catamaran's special unique catchment system. The boat is designed so that the front allows plastics to go through and into the catchment system. This 2.8 meter cube catchment system allows for the boat to skim and collect plastics. Once these bins are full, the men will take the boat back to shore where it will be then put by a dock. A unique feature of this boat is that it does not need to be permanently docked like most boats, in that it can just stay at the side. From there, a crane-like system can take the catchment system, raise it up, have the plastic inside properly disposed, and then re-put back in, allowing for a shorter time for when the boat is docked. This overall allows this kind of boat system to be one of the most efficient boat systems that we can implement. From there, I will talk about the other catchment system in rivers, which is a boom receptacle catchment system called the interceptor from Ocean Life. In the picture shown, the interceptor is located in the Klang River in Malaysia. First, the booms strategically orient the plastic to the front of the interceptor. From there, a conveyor belt system helps raise the plastic from the river into the interceptor. The unique feature of the interceptor is that it is connected to the internet. So as the plastics are being distributed, they are being distributed in 4 different catchment systems. And as plastics fill these catchment systems, the interceptor updates how much weight is in each system and is able to relay that on shore. When one of these 4 catchment systems needs to be emptied, it sends a message to shore where it can alert and send a boat out to come collect that full bin. From there, the bin is taken ashore and properly disposed of. Once this occurs, the bin is taken back out to the interceptor where it is continued being collected. Overall, the interceptor can hold 50 meter cubes worth of debris. And then from there, on a daily basis, it can collect roughly 50,000 to 100,000 kilograms of debris. Compared to the honorary catamaran, it can collect a bunch more. The only problem with this kind of system is that it takes a lot more setup to implement. But once implemented, this system can gauge itself and collect reliable data that can be then further used to help make the most efficient process of cycling and processing plastics. Now that I've talked about some river systems, I will now talk about some ocean systems. The main ocean system I will talk about today is System 001/System 002. System 001 from Ocean Life is a large boom-like U-shaped system. The current and wind are able to navigate the system so that the opening is at the most optimal position so that the ocean tides naturally are pushing the plastics into the boom-like system. With the self-orienting capability, it leaves little to no manpower besides coming out and making sure that the overall system does not have too much plastic, and when it does, being properly disposed of. Again, it is also connected to internet, so it is able to relay information and updates. This was very successful overall and makes it a huge contender for being able to effectively clean oceans. The only reason the System 001 failed was that the welding between two boom flotation devices was not welded on correctly. It accounted for the wind and tide, but unfortunately did not account for the weight of all the plastics as it was collecting. This made about 1/5 of the boom break off and float off into sea. Overall, though, this was a very successful project, and with slight modifications, System 002 is projected to come out of summer of 2021. This is going to be a huge contender for us to potentially invest in, and could be a huge change in how we clean oceans. Now that I have talked about some ocean systems, I will talk about what we have discovered and covered today. Today I talked about some of the feasibility of reducing marine plastics. First, I talked about river systems. River systems can cover about 80% of all plastics that end up ending up in the oceans. River systems, from this regard, make it a lot easier to target the source of most ocean plastics, and are therefore one of the best methods that we can actually implement. The other systems we talked about today are ocean systems. Ocean systems cover a lot about what we already know is a problem. The only main issue is that a lot don't cover or have failed to cover so far. But with significant progress that we have seen, I think that System 002 will be a huge contender to cleaning oceans. Overall, my best recommendation so far would be going for river systems, especially the honorary catamaran, as it is very little work to set up. It only requires minimal manpower. It's through these kind of systems that we can implement that can change how marine life are in our oceans. We can improve the longevity, which is our main mission as the San Francisco Bay Aquarium, is improving the life and longevity of species. And it is through this kind of research and these kind of devices that we can be able to reduce plastics and make it more impactful and have less cases of sea turtles and other marine life consuming plastics and feeling like their stomach is full. I appreciate your time today, and thank you very much.